we're starting a little bit late this round, but I'll try to take about 45 minutes or so and see how it goes. Yep, so this discussion is about testing web applications with Spring Framework 3.2 and some of the new features we added over the past year in the 3.2 releases. I assume everyone was here this morning for the keynote, so I won't really talk about myself, other than I'm a Java developer and a Spring consultant with the company I founded in Zurich called Swiftline. And I'm a core Spring committer. Especially important for this talk is that I'm the author of the Spring Test Context Framework. So for Spring 2.5, I completely rewrote all of the testing support that had previously been in Spring, and I've been updating it, adding new features, and maintaining it ever since. But one point about the code today, I did about half of it, and the other half was done by a guy named Russell Stoyanchev, who's a full-time Spring Source employee, and he did the actual Spring MVC test part since he actually maintains and develops Spring MVC. So, show of hands, who here now has actually used Spring in the web tier? Okay. And who has used Spring's testing support, so integration testing support? Fewer people. Who has used Spring MVC test? The same people. Wow, okay. So pretty cutting edge. All right. So the agenda, first we'll talk about the Spring Test Context Framework and upgrades that have been made to that, updates. I'll refer to it in different ways, sometimes just the Spring Testing Framework, Test Context Framework, etc. And the new Spring MVC Test Framework that's been integrated into core Spring as of Spring 3.2. And at the end we'll follow up with a Q&A if you have any questions. So, what's new in the Test Context Framework, the TCF? First and foremost, just some upgrades to libraries that are now supporting, or at least tested with, JUnit 4.11 and Testing G652, but you can still use older versions back to JUnit 4.5 and Testing G6 something or other. One of the main new features that's had been requested over many years, and I just never got around to developing, I did actually implement for Spring 3.2, is the ability to load a web application context. Yes? Okay, I will try to speak more slowly. Loading the web application context is a big new feature. Also, this allows us to test both request and session scope beans. We'll see some examples of that. Another smaller feature is support for application context initializers, something added in Spring 3.1. We'll look at that as well. And last but not least in this regard, loading context hierarchies was not added in Spring 3.2. Because I didn't finish the work, but I finished the work by 3.2.2, so it's available as of 3.2.2. And there are some more smaller features and updates that were made in the testing framework and testing support in general. If you want more information, I don't have time in this 45 minutes to discuss it all, but Ross and I gave a talk back at Spring 1.2GX in Washington, D.C. last year. You can find that online, and it has a lot more information there. So, one of the key things that we do again is the support for testing web applications. So to test the web application with Spring MVC, you probably want some way to load your web application context within your integration tests. So how can you tell the test context framework for Spring to do this? To load a web application context as opposed to a standard application context? The answer is quite simple. Just annotate your class with this new annotation called @WebAppConfiguration. That's the simple answer. But a bit more details about that. So basically the presence of this annotation tells Spring that the application context loaded for your tests should be a web application context, meaning that it should know about like the server context, etc. And in the background, it configures some stuff for you. Allows you to configure stuff such as the resource path for your web application. This will be used in the background by Spring's mock server context, and the path defaults to source main web app. So if anyone's used Maven before and built a web application with the Maven archetype for web apps, you'd be familiar with this path. This source main web app is lies alongside source main Java, source main resources. Source main web app should be the path to your web application, to the root of your war file, for example. And by default, paths are file system folders. That's in contrast to some other support Spring. They are not class path folders by default. We're in the class with resources. However, you can override that using the class path colon prefix. It's also used throughout the Spring framework whenever you're referring to resources. Let's take a look at a few examples of using this web app configuration annotation. Typically, this will be used directly in conjunction with @context configuration, which is an annotation from the Spring test context memory that tells Spring how to load your application context, from which configuration files, in terms of XML files, or which configuration classes. So we see here, we're just declaring web app configuration without any attributes, parameters, and the same with context configuration without any attributes there. So what we want to notice here is what the defaults are. By default, as I mentioned, web app configuration will look in the file system for source main web app for that folder. And in contrast, context configuration will look in the class path, not the file system, but literally just look up a class path resource based on the name of the class, and then adding the -context.xml suffix to that. And then in the same package as this test class. So we have a contrast here. With the web app configuration, we determined or decided it made more sense to look in the file system by default, because that's how you're going to be building or maintaining your module within Maven structures, for example. And with context configuration, it makes more sense to have class path resources. Now, what if we add values here, attributes, without specifying whether it comes from the file system or the class path? Then we see here with that web app configuration that the default will be a file system resource. So relative to the root of our JVM. So if you're running in Eclipse, or if you're running your Maven project, then it's going to be relative to the root of that project. And for context configuration, again, this will be a class path resource. If you prefix it with a /, it's going to look in the root of the class path. Otherwise, it would be a class path relative resource. Last but not least, in this collection of examples here, we see that we can override in both cases. So we can always override the default resource type, specifying either class path colon in this case, or file colon in this case. And that's it for the basics with web app configuration. So basically telling Spring how to, that you want a web application context loaded, and also where the root of your web application is. Now in the background, you might not need to use this directly, but it's sometimes good to know how things are working in the background. There's a test execution listener. So within the test context framework, there's this listener API you can implement if you want. However, normally you just use the ones out of the box for dependency injection, transactional support, and now this new servlet support as well. So what this does is that in the background, it sets up the default thread level state in the request context loader, which is an internal detail of Spring MVC that you might be familiar with that. And it does that for each test method, basically so that when your test methods execute, that they have the right web context set up for them. And to do this, it creates several mocks. So this mock HTTP servlet request from the Spring test module, also the mock HTTP servlet response, and a servlet web request that kind of wraps those together. It also makes sure that you can inject these mocks, so this mock response and servlet request, into your test instance. So in your test class, you can actually have that auto-wired in and access that in order to configure the mocks. And at the end, as you would hope, it cleans up the thread level state, making sure that you have tests running in isolation, so one test doesn't adversely affect the next test. As an example, we see here, so WAC tests, whenever I say WAC, it just stands for Web Application Context. Again, it's annotated with @web app configuration and @context configuration. And then using Spring's @auto-wire annotation, we can inject several of these instances into our test instance. So for example, the web application context and the mock servlet context. We see another comment or additional comments here that these two are cached. So in case you're not familiar with the Spring test context framework, one of the big benefits of the test context framework, as opposed to just loading an application context on your own within your integration test, is that when you're using the test context framework, application contexts will be cached across execution of your tests, so across the execution within an individual test, so across test methods, but also within your test suite. So if you're running hundreds of test methods against the same application context, or a small set of application contexts, those contexts will be cached, and you won't have the the negative runtime performance hit of reloading those application contexts. So this server context, this mock one, is directly associated with the web application context, and therefore those two are cached for you. If you're interested in having that cleared from the cache, you can look at the @dirty's context annotation. And then these other ones, so we have these three mocks. You can inject the mock session, mock request, mock response, and last but not least, the servlet web request can also be injected into your test. So we'll see some examples with session request scope beans for how that can be useful. Who has actually used a session or request scope bean? Few people, okay. Well, I have here a quick review. Basically, in Spring, beans have a scope that they're in. Typically, you would say you have a singleton bean, pulling the singleton pattern, there's only one. Then you can say you want a prototype bean so that you get a new bean each time you request it based on a certain blueprint. And then in a web application, we have additional scopes. So we have one for the request, and that means that the lifecycle of that bean or that component is tied to the current HTTP server request. So the user clicks something in the browser, sends a request to the server, and then a bean gets created for that request, and the bean goes away after that request, so after the response is sent back. And then for a broader scope, we have session scope, and that ties in, as you might expect, to the current HTTP session. So if you have a user that's logged on to your application in a certain container like Tomcat, then for the lifecycle of that session, you can have a component, a Spring managed bean, that's tied to that session. Now, in the past, it was rather challenging to test these things on your own. You would have to do a lot of boilerplate code on your own. But now with this new support, we'll see that it's pretty easy to test this, pretty straightforward. So here we have some example XML configuration. For Springs, we have a user service. This user service has a reference here to a login action. And then if we look at the login action, we see that it has, well, it's just defined as normal, takes some parameters, username and password, but there's three important things to note. So first off, we say scope is request. By default, it would have been a singleton bean. We're saying we want it to be tied to the HTTP request scope. And one thing that's required there in Spring is to use this AOP scope proxy. If you leave that out, it won't work like you expect. If you want to go more about that, you can ask me later or look it up in the reference manual. But another thing to note here is this use of hashtag, curly brackets, and then little expressions. Who's familiar with the Spring expression language? Fewer people? Okay. So this is basically use of Spring's expression language to basically pull in dynamic values from somewhere and pass them in either as constructor arguments or properties. Here we see these are username and password are being passed in as constructor arguments, and they're pulling information from the current request. So this is actually the HTTP servlet request, and we're just invoking the get parameter method on getting user and password from the current request, passing that into our login action. This is just an example of how one could do something like this. The main point here to notice is that we have a user service. It's a singleton bean. There's only one of those, and it gets a reference to a login action that pulls information out of the current request. So now if we wanted to test that, we would probably want to somehow set up the request, set up a test username and a test password in that request. And we can see here how we would do that. This example is using JUnit 4 and the JUnit @runWith annotation, then specifying the Spring runner here, Spring JUnit 4 class runner, to say I want to use the Spring Test Context Framework in JUnit. And then we see these two annotations that we've seen before. So @context configuration says we want an application context loaded, and @web app configuration says we want explicitly a web application context. And as I mentioned before, when we have this configuration, we can auto-wire in the servlet request, for example. We could also auto-wire in our user service. So in this case, the user service is the SUT, or the subject under test. So the thing we're trying to actually test. And we remember from the previous slide that the user service uses the login action, and the login action needs some information from the current request. So in our test, we could do something like this. With this mock HTTP server request, we can set up some test data, some test parameters. Here are the username and password. Then we can invoke a method on our subject under test. In this case, invoking the login user method on user service. We know that in the background, this method must somehow interact with the login action, and then we could assert some results. The main point here is though that we are loading the web application context, having the mock request injected into our test instance, setting up the mock as we expect, executing our subject-centered test, and then verifying some results. Similarly, we can do the same kind of thing with session scoped beans. Here we see again the user service, but this time it takes a reference to a user preferences bean. And again, we have a scope. Instead of a request, this time we have scope is equal to session. Again, it's a scoped proxy. And again, we are using a spell expression to access the current HTTP session in the server container, pulling out an attribute from that. For example, here, the theme, maybe a UI theme that we need to display or do something with. Again, we have another example with JUnit. Same setup at the top, specifying to use the Spring Runner. We want an application context, we want a web application context, and this time, instead of injecting in the request, we can use @AutoWire and have the mock HTTP session injected into our instance. And then, again, like we saw before, we can basically set up our expectations on the mock. So with this session, set some attribute, maybe setting the theme to blue, and then invoke our user service and assert the results. So the main point here is that in the past it was somewhat difficult. There was a lot of boilerplate code you had to do on your own to get this set up. And now with this new support for loading a web application context in the testing framework, you can have your application context cached, and you can easily inject in the session and request, set your expectations, and then invoke your code that uses either session or request scope beans. Moving on, this application context initializer, as I mentioned before, this is an interface introduced in Spring 3.1. What it does, it allows you to programmatically initialize or configure your application context. So in instance of configure application context. Typically this is done if you want to register some custom property sources or activate certain profiles against the environment. So again, new features in Spring 3.1. And normally this is done for a web application. So with a web application using Spring MVC, for example, there's first class support in Web XML for the context loader listener. So if you're configuring your root web application context, you can specify a context param named context initializer classes, and then the fully qualified package name of some classes you've written that implement this application context initializer. And similarly for Spring MVC, for Spring REST, etc., you can configure your dispatcher servlet with an init param, passing it context initializer classes to tell it which initializers to use to create the application context for your Spring MVC dispatcher. And if we want to use these in tests, so again, this application context initializer interface was from Spring 3.1, and the testing support for it was introduced in Spring 3.2. So with this add context configuration annotation, there's now a new initializers attribute that's been added to that. It allows you to configure basically an array of initializers or a single initializer by specifying the class. And by default, these initializers will be inherited in a test class hierarchy, and you can control that if you need to via the inherit initializers flag, for example, setting that to false. Something that's also new is that in the past, initially you had to specify XML locations, then you were allowed to specify XML locations or configuration classes with support for Java config, and now with this, you can leave off, if you want to, the XML locations or the annotated classes, and just specify application context initializers that will configure your application context if you want to somehow programmatically set up your entire application context. And in terms of caching, I mentioned before that your application context will be cached across indications of test methods, across test classes in your test suite. And these initializers also play a role in that, in the context cache key, so determining uniqueness of an application context. So Spring knows when to cache or when to look, or how to look up, or possibly already cached application context. And in terms of ordering, if you specify more than one initializer, there has to be a deterministic execution order. This is true in production and also in tests, and that's controlled by Spring's order interface or by the presence of the @order annotation on those initializers. So here's an example. Again, it's a JUnit example with a run width and specifying the spring runner. This time with that context configuration, we're specifying an explicit location here, and we're specifying some initializers. So again, there's just an array of class references to initializers that we want to test with. So maybe we're using these initializers in our web application context in production, and we want to make sure that our tests, that the application context loaded for our test is initialized the same way. Or maybe we have some special kind of test initialization that we want to do with the application context. We could also write that in an initializer. Context hierarchies. I mentioned before, right, there's a root web application context, and there's a dispatcher application context in your typical Spring MVC application. But traditionally, in the testing framework, we only supported flat, non-hierarchical context. So just one level. You could have specified multiple configuration files, but those would all be merged just as in production, and then you'd have one application context for your integration test. This meant that there was no easy way to set up a parent-child relationship for your context, even though this is supported in production and, in fact, very typical in a Spring MVC web application. So, the question is, would it be nice if you could test them too? And the answer is yes. As I mentioned, add the support in 3.2.2. And to configure this, there's a new annotation. There's an @context hierarchy annotation, which is used in conjunction with the existing @context configuration annotation. In addition, the @context configuration annotation has been augmented with a new name attribute. Typically, you don't even need to set this, but if for some reason you need to either merge or override configuration within a hierarchy across a test class hierarchy, then you can specify names, and then you can refer to names at other levels and override or merge. As an example here, we have a single class, test class, so this is not a test class hierarchy. There's no inheritance in terms of Java inheritance. But with the use of @context hierarchy, we do have inheritance in the application context. So the constellation of contexts that we have loaded for the test will first have one loaded from parent.xml and one loaded from child.xml. So if you visualize that and kind of in memory in your mind, you have a parent application context and a child application context, and the child references the parent. So that would be analogous to your root web application context and your dispatcher application context in the web MVC application. Here we see a more fleshed out example, so a bit more detailed with 3 classes in a class hierarchy. So we start at the top of an abstract web test, and we're specifying here, yes, we want to run it with JUnit, the Spring Runner. We want our web application context loaded, and we want this context configuration. So with this application context, we want this XML file to be used at the base of our tests, and at the top, if you want to think about it in terms of hierarchy. Now, we have some classes that extend from that. So here we have SOAP web service tests and a REST web service test. Both these classes extend this abstract web test, specifying this new annotation @context hierarchy, and each time specifying their own context configuration. So this makes sense here. For the SOAP one, we have SOAP WS config, and for the REST one, we have REST WS config. What you end up with there, when you run this set of tests, you would end up with 3 application contexts that are loaded and cached. Right? You'd have this parent one at the top for application context. You would have then 2 child contexts, so SOAP WS and REST WS, and each of these would point to the parent application context. Another thing to point out here is that at the top, we actually don't have context hierarchy. So we have @context hierarchy at this level, @context hierarchy at this level, and in this abstract web tests, we don't specify @context hierarchy. We could have, but you don't have to. And the reason I point that out is that you might have some existing abstract-based test classes or some existing classes you're extending from that already declare application context and are used in different ways within your test suite. You can continue to use those and extend from them, and as soon as you specify @context hierarchy at one level in your test class, then that test class and any subclasses will participate in a context hierarchy. So I guess another point there is, don't be confused that just because you don't see at context hierarchy at the top, that if a subclass includes it, then you will actually end up with a hierarchy. That's kind of a thing to note so that you don't get confused if someone else wrote the configuration, for example. So that's it for the updates to the Spring Test Context Framework in general and the basic web support. And for the second half, we'll be talking about the new Spring MVC test framework. So what is Spring MVC test? First and foremost, it's a dedicated support for testing your Spring MVC applications, obviously. It has a nice fluent API, which is really comfortable to use, very easy to write, hopefully easy to understand as well. And it includes both client and server-side support. So for testing things, you're developing on the server side or your client web interactions. Sorry. Another nice thing to note is that it does not actually require a server container, so it's an out-of-container integration test, which means it's going to run very relatively quickly and can tie into the nice caching mechanisms of the Spring Test Context Framework as well. Some of the details. It is actually included in Spring 3.2 as part of the Spring Test module, so alongside the Test Context Framework and existing mocks, etc. And it builds on the Test Context Framework for loading your MVC application contexts, as we just saw in the previous slides with the new web app configuration, annotation, etc. And it also uses the existing mocks that we have for requests and response within the Spring Test module. Those have actually been around for years, and they're just used internally within the Spring MVC test framework. So when you're executing server-side tests, this actually involves a real dispatcher server. In fact, it's a subclass of that, but for all practical purposes, it uses a real dispatcher server. It's of course not a real request. It's not an HTTP request. It's not going through a server container, but it starts at the intersection point of the dispatcher server. So in that sense, you'll be using your real Spring configuration. Your controllers will be actually executed that would be in production. Your mappings will be handled the same way, etc. So it's almost like running it in the container, just without the startup time and the maintenance for having to have a running container for your tests. On the client side, so we want to test, or for code that uses REST, and using the REST template, we can also use that with the testing framework, and we'll see that towards the end. A bit about the history, where it came from. Some of you might have heard about it before we actually released it with Spring 3.2. So it evolved at first as an independent project on GitHub at Spring Source Spring Test MVC, but we did integrate it fully into Spring 3.2 with the new ability to load a web application context with the caching and the test context framework. But the old project there, Spring Test MVC, still exists and still supports Spring 3.1. So if you want to use some of this functionality, maybe not exactly as you see here in the following slides, but there is still, what's good to know, there's still support for Spring 3.1 using the old version here. So you probably want to see some examples. Here we have one, combining some of the stuff we've seen before. Sample tests, again, JUnit run with the Spring runner. Again, we want a web application context, so we say at web app configuration. And here we're saying at context configuration specifying, for example, server context. Now, what we're doing, we saw earlier that we can do this using @AutoWire to have the web application context injected directly into the test. And that's actually very, very important here, as we see in this before method. So this JUnit at before in our setup method. We have a mock MVC instance. This is from the Spring MVC test framework. And we're going to instantiate it with this is a nice static method that's been imported. So this web app context setup, and it needs a reference to the web application context. So this.whack is referencing the web application context that's loaded for us and cached for us by the test framework configured here via JUnit. There's some other options here we'll see in a minute. Here we just say build, and we have access to this mock MVC instance. And within our tests, so maybe for example here, we want to test our foo get request to the path/foo. So we can just say mvc.perform get/foo. And also to send with that request, we want to send acceptance headers of application JSON, and then once that request is executed in our Spring MVC application, after it's gone through to the controller and the controller has returned, then we can add some expectations. So here we see and expect that the status is okay. So a status of 200 was returned in terms of HTTP response codes. Here we can say and expect a particular content type specifying a MIME type. And we can expect JSON path that we pull out some value out of the JSON path if this controller should have returned JSON. You know about the fluent API usage. I mentioned that one method was a static method. And to make this nice and pretty and readable within your code, you're going to want to use the static imports. So for example, import static, mock MVC request builders, get, etc. Then you have some nice stuff here. So this get and status, you don't have to explicitly reference where they come from. And if you want that to work nicely, for example, in Eclipse with control space, with nice code completion in your IDE, then you can add these as what are called favorite static members and Eclipse preferences, Java editor conferences, favorites. So it's highly recommendable. Also for things like even your org JUnit assert or hand press matchers, etc. So for the server side, to recap on that, the actual Spring MVC configuration will be loaded. So there's application context or potentially Java configuration classes that you referenced with add context configuration. Those will load your app or configure your actual Spring MVC configuration. And in the background, a mock request is prepared for you. And then when you actually perform either the get or the post or whatever operation against your controllers, then it actually executes against this dispatcher server in the background. Then on the other side, your assertions will be applied to the resulting mock response that's managed for you in the background. So you might ask yourself, is this integration testing or is this unit testing? Or I'm not starting a real Tomcat server container or a Jetty server container, so maybe it's unit testing. And we're also using mocks, right? So there's some mocks. We saw the mock request and mock response in the server container. It sounds kind of like unit testing, but in actuality, you're really starting up a Spring application context. So you basically kind of have a Spring container, if you want to look at it like that. You are interacting with the dispatcher server and your actual Spring MVC configuration. So in that sense, this is an integration test between your code, between your controller, Spring is running, and your Spring configuration. But at the same time, it's not truly fully end-to-end testing, so this doesn't replace something like Selenium if you have some needs like that. But at the same time, it does provide a really high level of confidence in your Spring MVC layer in terms of the configuration, but also in terms of your things like mapping, content, MIME content type support, automatic type conversion, marshalling, and other things like that. So in other words, you can really test a lot of the functionality of your Spring MVC application or your Spring MVC REST application without deploying it to a container. In terms of strategies, you should focus on testing the Spring MVC web layer alone. Basically, that's a standard testing strategy, like focus on one layer or one unit or as small a piece of the application as you can. And to do that, you would then want to inject into your controllers mock services or mock repositories. So whatever collaborators your controllers have, you want to mock those out following the standard POJO programming model, programming interfaces, makes it easy to provide mocks. And you want to thoroughly test your Spring MVC configuration and the code. So it's not just the code, it's not just a unit test for the code. You want to test the configuration, make sure that you configure Spring MVC the way that you think you have, so that your request mappings are right, so that your marshalling and automatic type conversion things are happening as you would expect. In terms of mocks, who actually uses mocks? You guys using JMock? EasyMock? Makito? Okay. Right. So since we're actually learning the real Spring MVC config, we first want to declare a mock dependency for things like our services or repositories. And here we have an example. So here we have a Beam class using Word Makito Mockito and specifying a factory method for this. So this is mockito.mock is basically what will be invoked, and we're passing a fully qualified class name of the repository or the data access object that we want to mock out in this case. And hopefully everyone's at least maybe familiar with the concept of a factory in terms of design patterns. So this will create an instance of type food.out, and then you can have that food.out injected into your food service, etc., into your test as well, or into your controller. Yes. And then in terms of expectations on the mock, you can set this up via at before, at test, and at after methods, etc., just like you would any other mock. But you're configuring this, yes?
Can I have a question? In practice, AutoWire does not work with this type of mocking. Just because.
Are you sure? As a 3.2? Because I fixed it.
Yes. In most cases, it argues that there is no bin with a matching type. It works with add resource, just because it first checks for the name and then gets at the actual type.
Have you tested it in 3.2?
Yes.
Yes.
3.2.3. Yes.
Yeah. 3.2.3 hasn't been. Well, then show me, because then it's a bug. If you're doing it like this and it doesn't work, then it's a bug, because I wrote code in 3.2 that fixes that.
It doesn't work.
Okay. Show me later. I have some more work to do. If you're talking about, there's one situation where it doesn't work, but if you're doing it just like that, it really should definitely work. So, what can be tested? We've seen a few things, but we'll talk more in detail now. We can test the response status, so like the code, with 200, etc. Headers that were returned, and the content. And we should really focus on asserting these kind of things first, because that's actually what's going to be sent back to the user, or that's kind of the focus of actually generating some kind of content. But if you need to, you can also test some Spring MVC and server-specific results. For example, in terms of Spring MVC, you could work with a Spring MVC model, flash scope, session scope, request attributes, etc. And you can also test the map control methods and interceptors, and you can verify whether or not exceptions are properly resolved based on your configuration. There are also various options for asserting a response body, so the content using either JSON path, XPath, XML unit, etc., and also various campath matchers, so you can even provide in your own custom matcher if you want to. But what about the view layer? So we haven't really talked much about that. In general, all view templating technologies are supported. So if you're using stuff like FreeMarker, Velocity, TimeLeaf, etc., even things like JSON, XML generation, PDF generation, those should all work, just as you'd expect in a real container. The caveat is JSPs will not work because we're not running in a server container, as I mentioned before, so we don't have the JSP compiler there to actually compile your code and invoke it. But on the positive side, you can assert which JSP was selected. So if you had a forward or a redirect or something, you can verify that that happened as you expected. And in terms of redirection forward, there is no actual redirect or forward since we're not in a container, but you can verify that an attempt was made to redirect to a particular URL or forward to a particular URL. Some other features that are available, experimental features, so support for HTML unit and Selenium drive integration. If you're interested in that, you can check out this Spring VC HTML unit project. It's a repository on Spring Source's GitHub repository. Now, debugging. There's this handy little feature here. If you add in after your perform statement and do print, then you're saying basically print everything that happens in terms of this request and response processing within the Spring test or Spring VC test framework, and that will print that out to system out. So if you're having any issues, it's kind of easier to look at that than it is to try to debug all the internals of Spring VC and the dispatcher server, etc. And you can also debug and set breakpoints if you want, but this is a really quick way to take a look and see what's happening. In terms of configuration, we also have standalone setup And what that means is that we're not providing our own Spring configuration. Instead, we want the defaults for Spring MVC to be used. And when we do this, we're going to test one controller at a time. So we're not testing potentially multiple controllers loaded in our application connects. Rather, we're focusing on one particular controller, and we'll see that on an example. The way we do that is we provide a reference to the controller instance. And we can do it like this. So here we have redirect tests, mock MVC. We need an instance of that in our setup. Instead of creating a mock MVC instance from the web application context loaded by the testing framework, we're just saying here standalone setup for this given controller. So passing an instance of a particular controller. Then in our actual test method, this looks the same or similar to what we had before. So here performing a post with some parameters, expecting particular status to move temporarily, and expecting a redirect URL. So your actual test methods will look the same. The difference here is that you are loading a standalone setup, and Spring MVC test is creating, again, the dispatcher server in the background, and a little miniature MVC configuration for you using all of the defaults. Now, if you have any needs to override some defaults, you can override those here. In addition, you can also set up server filters. So if you have your own server filters you've written and you want to see how they're interacting properly, you can configure those via the add filters method here, passing in a bars list of filters there. Another testing case, use case, is if you're using Spring Security, for example. If you're having a Spring security configuration loaded, you can basically take the Spring Security filter chain and pass that in to the add filters method and make sure that Spring Security is executed in your integration test as well. Are we on time?
5 minutes.
How many slides do I have? We'll see. All right. Moving on. So we want to reuse some configuration. Maybe we have some configuration we find ourselves typing all the time. We don't want to violate the dry principle, so do not repeat yourself principle. We want to reuse some configuration. So in our setup method, we can set up things like default request and always expect. And then in our actual tests, we could override those if we wanted to, or just rely on the defaults that we've set up for all of our common needs. Now, there are times when you need access to the underlying MVC result. So up to now, we've had this mock MVC, but we've just had things like here, perform and expect. When we were done, we didn't actually interact with the result on our own. In this case, MVC result, we want to take that. We can actually get hold of the request and response, the model and view. And for example, if you're testing asynchronous execution support, you want to get hold of the MVC result and make sure that the code is invoked asynchronously. Now we're moving on to client-side REST. So all that before is server-side. Now we're talking about client-side. We'll create a Spring MVC REST template, just as we normally would. And now instead of the mock MVC, we're using this mock REST service server, create server, passing a reference to the REST template. And then on that mock server, we have some things somewhat analogous to what we had before, but we're expecting our code to perform a request to this path and to respond with, for example here, with success and the MIME type, etc. Then we would invoke our client code that we've written that uses this REST template, and at the end we can call verify on that mock server to make sure that our client code, our subject under test, did in fact interact with the REST template in the ways that we specified. So you're using an instance of REST template, just as you normally would, but in the background it's getting configured with some custom client HTTP request factory that's responsible for recording and inserting the expected results instead of actually executing them. So you're not going to literally talk to any kind of remote server. It's just going to basically catch those requests and record them. And then your code that uses the REST template can use the REST template as it normally would. So one slide acknowledgement. If some of this code looks familiar to you, maybe you used Spring Web Services, and Spring Web Services has a similar testing framework with a nice fluid API. And in fact, the Spring MVC test support was inspired by that code base. In closing, just like to say special thanks to my colleague and friend Rosalind Stoyancha, the lead for Spring MVC, who allowed me to reuse some of his slides on Spring MVC test, and for some further resources. Hopefully those who are familiar with springsource.org, so the home for Spring projects, and Core Spring is, of course, under Spring Framework. Forums, I mentioned previously, if you have any questions, want to interact with some other developers, you can go to the official forums or perhaps look at Stack Overflow and search there, post questions, and if you find any bugs or have any things you'd like to recommend, please, by all means, log into Jira, create an account, and let us know what you find. And if you'd like to contribute, I highly recommend you check out the repository on GitHub. There's a nice set of wiki pages there, guidelines on how to become a contributor, guidelines on how to submit a reproduction issue project, for example. In terms of Spring MVC test resources, there's a nice blog post from Russ Soyancha. If you were to click here, and I'll make these slides available. Also in terms of samples, so there's this Spring MVC showcase collection of examples that's available on GitHub, and that has been reworked to use the Spring MVC test framework for testing some of the Spring MVC code. And there are also some example server tests and client tests that are part of the actual Spring testing suite. And reference documentation has been updated, so within the testing chapter of the Spring reference manual for Spring 3.2, there's a new set of sections covering this web testing support as well as the Spring MVC test support. In terms of blogs, I have my company blog where I blog about every now and then, usually per Spring release, about the newest features in the testing framework. And there's also, of course, the Spring Source team blog for all the core news and updates about new features in not only Core Spring, but any of the Spring portfolio projects. So that's it. If you'd like to contact me, here's how you can do it. Here's how you can look at my slides that I've published on SlideShare. If you have any questions?
Yeah, just one. You mentioned this JSON bass stuff, and it has its own dependency. It's some external.
It's an external framework, yes.
Yeah, but it's kind of weird. So you're just starting to using it, and you get exception that the class not found. Are you planning to, I don't know, include it or?
No, there wouldn't be any plan to include it. So whenever there's a reference to a third-party library, it's an optional dependency, meaning that you can use that module, so the Spring Test module. It's the same with JUnit and TestNG. If you don't have JUnit and you try to use add run with and run it in Eclipse or something, then it wouldn't work, right? You couldn't. I guess you're saying the difference is that you don't see a compile time dependency. It's a runtime dependency. But things like that we wouldn't include because there's so many developers that use the test module for other reasons that have nothing to do with web and JSON. Yeah?
Are you going to support JSPs in some way in the future?
Not that I know of. It's a lot more challenging to have the JSPs compiled and all that. It requires a lot more dependencies. It's going a lot farther beyond the notion of an out-of-container integration test. It's really much more like in-container at that point. It's one of the downsides of JSP in general. That's why a lot of people really like things more like timely and pre-marker and stuff.
Thank you.
In some of my previous projects, we use Spring Test with JUnit. After some point, we decided to move to TestNG. But just replacing the runner from JUnit to TestNG does not work. Some part of stuff just stopped to initialize. Is it something on our side, or is it supposed to work?
You extended one of the TestNG base classes when you moved over. That's what you're saying.
We use run with JUnit runner, and we want to move to TestNG runner.
There's no TestNG runner. In TestNG, you have to extend one of the abstract base classes. So in theory, it's supposed to work exactly the same, except for one thing, and it's a known issue that timed transactional tests don't work in TestNG, but I doubt that that's what you're doing, since very few people do timed transactional tests. But otherwise, it should work the same. If it doesn't, then that would be a bug, and I would appreciate it if you create a Jira issue or let me know. Yeah?
For example, if I want to write my own JUnit or test engine, sorry, my own Spring Runner, where I can get info about how to do that?
Sources.
Your own Spring Runner. So it's not actually intended that you would write your own Spring Runner, per se. The test context framework is written to be agnostic of the testing framework that's used. So the runner is just a way to incorporate it in JUnit, and in TestNG we have these abstract base classes where you can basically orchestrate the tests on your own. The core is a test context manager. You have to instantiate one of those at the correct time and then invoke methods on it at the right time. So one example would be to look at the abstract base classes for TestNG. That shows how to use it kind of programmatically. And in terms of the runner, what I would say in either case, it's possible that you'll be able to achieve what you want to by writing your own, either your own test execution listener or writing your own application context initializer. So maybe one of those two things might be a better alternative than to trying to write your own runner. And as I was talking to you guys earlier, for 4.0, I want to make any promises, but it is on my plate of things to look at to come up with a solution using JUnit's at-rule implementation and at-rule mechanism as opposed to using the JUnit runner mechanism.
Thank you.
So I think that's probably time. She's not flagging this down, but